right, here we go.
It's good. But I did get an F on the...
We're going to do these word problems, only 4 of them, and they're easy. Find the area of a regular hexagon inscribed in a circle with a radius of 22 feet.
Who said 3? 8.
Hey, I need people to be quiet. All right. So, first of all, what do we mean by a regular hexagon? 6-sided figure. And regular means that they're all the same. The sides and angles are all the same. So, to draw this, you can do whatever you want. No one's grading your picture. But I like to go ahead and draw the circle. There's the circle. And then since it's a hexagon, I will put 6 hash marks, evenly spaced, and then I'll connect those hash marks, and there will be my hexagon inscribed in the circle. Now again, nobody's grading your picture, so please do not get all hung up about it. But I think it helps to have some kind of a picture to look at. Now, all I know is that the circle has a radius of 22. Right? So, actually, all of these would be 22. So if I went ahead and drew them all in, they're all 22, right? And drawing them all in like that actually divided my hexagon up into 6 triangles. And I just spent some time talking about how to find area of triangles. So, the area of the triangle, let's just focus right here on this triangle. Man, I'd be all set if I knew how big this angle was right here. Because remember, I can find the area of a triangle by doing 1/2 side, side, sine of the angle between them. Can anybody think of a way to figure out that angle right there? Yes.
A hexagon is 6 times 22, so wouldn't be, and they're all even triangles, so wouldn't you be able to just divide it by 3 and then divide it again by 6?
Okay, you are on the right track. Somewhere in there, something's a little bit off, but you're exactly on the right track. Did you hear what she said? She said, all of these angles right here are equal. Would you agree that angle, that one, that one, that one, that one, and that one are all equal?
Yes.
Because these triangles are all the same, even though my picture's not doesn't look like it, they're all the same. So how many degrees is all the way around that? 360. But that 360 has been divided up into 6 pieces. So isn't this just 360 divided by 6? So Campbell, you were right there. I'm just not sure. You were talking about 180, and I'm not sure what that was about. But yes, 360 divided by 6. So now, can't I say that the area of the triangle is 1/2 22 times 22 times sine 60? Kids, that's what we just talked about. 1/2 side, side, sine. Now, okay, we can do that. 1/2 times 22 times 22 times sine 60. Now, I got 209, did you? Yeah. Now, what's that, though? Be careful. That's the area of the triangle. So how do we get the area of the hexagon?
You have to multiply it by 6?
Multiply it by 6. So times 6. And I got 1257.47. And what was my unit? feet squared. Does that make sense to you? So, next time you see this problem, it might not be a hexagon. It might be an octagon. What will be different if it's an octagon, okay? So to get your central angle, you'll take 360 divided by 8. And then once you find your triangle, you will times it by 8, right? But otherwise, it's the same problem. Okay. Number 2. Now we have a parallelogram. This is a parallelogram. So if you have forgotten that shape, draw that picture. That's a parallelogram. A rhombus would be like that, except all the sides are equal in a rhombus. In a parallelogram, they're not necessarily. Yes. Now, the sides are 14 and 16. And the smaller angle, obviously you got a skinny angle and a fat angle in your parallelogram. The smaller one is 48 degrees. Now remember, in a parallelogram, opposite sides are congruent. So I put the 16 up there, this is also 16, and this is 14. And my job is to find the area of that thing. Now, how did we find the area of the hexagon? We split it up into triangles. What if I split this into 2 triangles by drawing in that diagonal right there? What's true about these 2 triangles? They are equal. They're congruent, right? Can I find the area of this one? Yep, the area of that triangle is 1/2 side times side times sine of included angle. Right, folks? So I can do that. That's pretty easy. 1/2 times 14 times 16 times sine 48. Okay. You get 83?
Yes.
Now that's the area of the triangle. So if you want the whole parallelogram, you'll have to double it. So times 2. So my area is 166.46 square centimeters.
Why is it split in half?
Huh?
Why is it split in half? Like, why couldn't you just do the first thing, like, for the whole thing? Does that make sense?
No, I don't think so.
Okay.
Because this formula, when you do 1/2 side, sine,
Yeah.
that's the area of a triangle. It only works for a triangle.
Okay.
So
Yeah.
that's
not a
why
triangle,
we
so then
split
you
it
split
into
it.
triangles. Because I can find the area of a triangle. That's what I did here.
Right.
I can find the area of a triangle. I can't find the area of a hexagon.
Okay.
But if I split it into a triangle, then I can get my area.
And then did you just multiply that, like, number by 2
Yep.
to get, okay.
Yep. All right, Roxy, you with me? Okay. Problem 3 isn't an area problem. It says go back to your parallelogram. Go back to this parallelogram and find the area, or no, excuse me, find the length of the longer diagonal. Okay, so here's my parallelogram. And I got a 14 and a 16 and a 48. Now, I want to remind you that these lines are parallel. So these two angles right here, look where I'm pointing, the 48 and the big one at the top, are supplementary. What does that mean when they're supplementary? They equal 180. So this angle right here is 132. So is this one, and this one's 48. Those are properties of a parallelogram that your geometry teacher taught you back in the day. Okay, so that's just given. They gave me that information, I know, because it's a parallelogram. Now my job is to find the longer diagonal. So this is a diagonal, and this is a diagonal. So you just have to use your common sense. Which one's longer?
48.
This one's longer, right? And I'm going to find the length of that diagonal. Now, I do not want you to get bogged down in the whole picture. Pick a triangle, either the top one or the bottom one, and that's what we're going to do. We're going to work on finding X in either this triangle or this triangle. It doesn't make any difference because they're the same. So look at whichever one you want. But you're finding a length. Now, you guys, we're not doing area. We're finding a length. And to find a length, you're either going to do the law of sines or the law of cosines. Those are your only options. Now, those of you that didn't watch the video are a little bit at a disadvantage here because you know nothing about the law of cosines. And you need to know it. But that's the one we're going to use because in this triangle, I do not have the right information for the law of sines. Now, there will be people who try to say this is 24 and 24, and it is not. I have no idea how big these angles are. I just know they add up to 48, but they could be 20 and 28. They could be 10 and 38. I don't know what they are. The only angle I know is right there. So I'm going to set up my law of cosines. X squared equals 16 squared plus 14 squared minus 2 times 16 times 14 times cosine 132. Those of you that watch the video know that in the law of cosines, your angle goes at this end, and the side across from it goes at this side of the equation. And then in the middle is side squared plus side squared minus 2 side. I'm going to type that in. So 16 squared plus 14 squared minus 2 times 16 times 14 times cosine 132. Now I got 751. Who watched the video and knows what I'm going to caution you about? What do we need to do now? Square root it. You got to square root that number. This is always, when you do the law of cosines, it's always x squared or a squared or something. So we got to square root it. So the answer is 27.42. So this is 27.42 centimeters. The longer diagonal is 27.42 centimeters. If the problem says find area, then we either do Hero's formula or 1/2 side sine. But if the problem says find a length, law of sines or law of cosines. Also, the unit on the length will just be centimeters, right? We only square it if it's area. And finally, number 4. We have another regular thing. This one's a pentagon. What does pentagon mean? 5. So I'm going to draw my circle, put 5 hash marks around it. There's my pentagon. And the radius is 28. Where do we go from here? We did one of these a minute ago. Everybody acted kind of like you knew what you were doing. What do you do, Kai?
Figure out
The angle, yep. Figure out this angle right here.
yes, no.
And how will I do that?
The circle is 360.
Mm-hmm.
So you gotta. Now I'm at a
Divided by 5. Yeah. A pentagon, 5.
Yeah.
So we're going to take 360 divided by 5. And what is that? 72? So I know my angle is 72. And now I can find the area of the triangle. What's my formula? 1/2 28 times 28 sine 72. Yep, 1/2 side. Now remember, that is the area of the triangle. So I got 372 for the area of the triangle, 0.81. But the pentagon, then, I'll take 5 times that. So just hit times 5. Don't retype it in, just hit times 5. And I got 1,864.07 square inches. You follow that?